Good day, good day, good day. Welcome back to our YouTube channel. So if you are new here, welcome. My name is Tifla and I'm the one that is going to be teaching you today. So today we just wanted to do esterification reactions, how esters are made, right? So just sit back, relax and watch this wonderful video. So esters are organic compounds which forms as a result of a reaction between a carboxylic acid and an alcohol. So an alcohol and a carboxylic acid reacts to form these esters. So carboxylic acid plus alcohol gives us the ester, right? And sulfuric acid is the one that is used as the catalyst. So also, just take note that many times when you are having sulfuric acid as the catalyst, it's either you are adding something with water or this water is a product. So in this case, water is a product. So carboxylic acid plus alcohol gives us the ester plus the water there. So water in this case is the product. So esters have a pleasant smell which often found in flowers or fruits. So these are found in flowers or fruits, right? So now we are going to see how these carboxylic acids and alcohol react to form esters and how to name the ester in question, right? And also how you can identify which alcohol and carboxylic acid was used to make a certain ester that will be given at that time, right? So this will be just a short video on esterifications only. So just a reminder, if you haven't subscribed, please just rush to subscribe, as this will help us and it will also encourage us to keep on making these videos. So please just subscribe very fast, right? So let's just get to the reactions. So let's take a look at this general equation of esters, right? So alcohol will react with the carboxylic acid under sulfuric acid to give us alkyl alkanoate, which is the ester, right? And the water molecule, like that. So let's take a look at this. So if you're having a situation where you're having an alcohol, so this is just a general formula of an alcohol, this representing a carbon chain of the alcohol, and this is the hydroxyl, right? So if this is reacting with this carboxylic acid, so this is also a carbon chain representing the carbon chain in the what? In the carboxylic acid. So we can notice the carboxylic acid by the carboxyl group. So this is the hydroxyl, this is the carboxyl, right? Under the influence of sulfuric acid. As you can see, this is coming from the carboxylic acid. So this sequence, or this with this double O there, it is coming from the carboxylic acid. So that's how you can notice that this is coming from a carboxylic acid. The chain that is having a C with a double bond of O is coming from the carboxylic acid. And the one that is close to this O is coming from the alcohol. And they form water there. So as you can see, that water, I wrote this in black and this in blue. So this means that this hydroxyl is coming from the carboxylic acid. So this OH is coming from the carboxylic acid, and this other H is coming from the alcohol to form the water there. So it means that this alcohol will keep its O, but its O with a single bond. Can you see that? It will keep its O with a single bond. And this carboxylic acid will keep the double bond O. Can you see that? So this is coming from the carboxylic acid and this is coming from the alcohol. And how to name this? We start with the alcohol name, and we name it alkyl alkanoate. So we're going to see in the next screen that how do we name these when we are given the examples, right? So let's take a look at this one. They gave us that ethanol is reacting with ethanoic acid. So in most of the questions, they give you 7 marks to draw a structural formula of this reaction. So we are going to do a structural formula of this reaction and also give out the name of this. So methanol, it is just COH. So methanol, we have 1 carbon atom, right? So this is methanol. So methanol is reacting with ethanoic acid. So ethanoic acid, it is 2 carbon atoms there, and we can have a double bond O, and we can have O with H there. So when this and this react, they will react under what? Sulfuric acid. So don't leave out this whenever you are having a question. So like I said on the previous section, I said this H is going to take this OH from this carboxylic acid and they'll form water, right? So now, what will happen between these two now? It means that we are going to have, where is that? We are going to have this carboxylic acid that remains as, can you notice this one is having a double bond there? So this will remain with a double bond, right? And now when this alcohol comes to this, it will join with this O. So this O will come there, and we have the C, or maybe let me do like this so that it will be quite visible enough. So this O is coming from the alcohol, so it will be, right? And it's C with this H is like that. So can you notice this O with that, right? And plus water, which will be just like that, right? So how do you name these carboxylic acids now? Because we're having a methanol plus ethanoic acid. So you first name the alcohol branch. So this alcohol is the one that we first name. So this alcohol is just 1 carbon, it will be methan, right? So we use methyl. Like I said, the name of esters, it's alkyl alkanoate, right? So the name from the alcohol, it will be, if it is 1 carbon, it will be methyl, 2 carbons, ethyl, 3 propyl, like that, right? And this one now coming from the carboxylic acid, because it was supposed to be ethanoic acid. So now it will be ethanoate. Now you take OAT. So this is methyl ethanoate. Methyl ethanoate, like that. You can recognize that this is coming from the carboxylic acid and this is coming from the alcohol. So methyl ethanoate. Maybe let's do another example. So now they give us a reaction between propane 1-ol and ethanoic acid. So just like the previous one, if you want the structural formula for the reaction, this is a propane 1-ol, right? Propane 1-ol. So this is reacting with ethanoic acid, which is 2 carbon atoms, right? So 2 carbon atoms, like that. So this is 2 carbon atoms. And something like that. So this is happening under sulfuric acid, like that. So like we said, this oxygen, this hydrogen, will take out this oxygen and this hydrogen from the carboxylic acid, and they'll form water from that. So it means that now we are left with this with 2 carbons. So this with 2 carbons, but the C, we have the double bond of O, and it will join to this O that is coming from the alcohol. So it will join the O from the alcohol, and the H, sorry, so we're having the C coming after that, so that will be C, H, H, C, C. Like that, right? So how do we name this now? So we saw that this is propane 1 all reacting with ethanoic acid. So we said how to name this. We first name this as a branch, right? So this branch, obviously it was on carbon number 1, like this name suggests, propane 1 all. So we also include that number, right? So this would be 1 propyl, because this is the alcohol, right? 1 propyl, and this is ethanoate, like that. 1 propyl ethanoate. So that's how you can name the the esters. That's how you name the esters. So this and that, I forgot to show that. So this and that will form the water there. So those will form the water there. As easy as that. That's how you do the esters, right? So as well as when you are having this, you can be given an ester and you are supposed to name that when they didn't tell you the reaction, or they can say which carboxylic acid was reacted to form this ester, right? So let me show you how you can find that. So also you can be given an ester like that, and they can say name this ester and also identify which carboxylic acid and which alcohol was used, right? So to name this, obviously we first have to identify what was used, right? So we can see that this O is close to these 2 carbons. So it means that this O is definitely coming from the alcohol. So alcohol with 2 carbons, it is a ethanol. So this is ethanol. And this that is having a double bond, it is only 1 carbon in its chain. So it's coming from the carboxylic acid, and which is the methanoic acid. So this is coming from the carboxylic acid, and this is coming from the alcohol. And naming this now, we just put everything together now. So we've said we first name the alcohol. So this is ethyl methanoate, as simple as that. So we're having this compound. Do you want to try it? So yes, so I will give you 3, 2, 1, 0. Okay, so obviously this is close to this carbon. So this O is close to this carbon, which is only 1, and we said the one close to this O, it is the alcohol. So that will be a methanol. And now this one with the double bond is having 3 carbons in the chain, so that is a propanoic acid coming from the carboxylic acid. And now putting the word together, we start with the alcohol one, so that will be methyl propanoate, just like that, as simple as that. So I'm leaving out this work so that you can try it out, and then I'll do a quick solution of this video afterwards, right? So maybe I'll post it the following day, right? So this one is saying balance the reaction using structural formula between ethanol and propanoic acid, and the following one, butane, 1-ol and ethanoic acid. And also using structural formulas, show how the following was made: propyl methanoate and ethyl pentanoate, right? So until then, I'll see you on the next one. If you haven't subscribed, please just rush to subscribe, and we'll keep on being loyal to you, giving you all that you need in terms of your educational journey. We are on your side. From us, Stifler Extra Lessons. See you on the next one.